So, having this question, this is where our assumption, the first assumption, can work. Now, when we look at this, we can see that let's our u to be x, because when it is simple to differentiate, and even when I differentiate to reduce the power to the nearest 0.4, and then we can say that let our dv is equal to 5 plus 1, or 5x plus 1, which is square root, which is easy to integrate, and you can write it in this form: 5x plus 1 all power 1 over 2, as you learned in your indices class. So having this, always what I tell my students is that when you get a question and you know, or you get to know that you have to apply integration by parts, just write down your formula, and the formula is square root of integral of u dv equal to uv minus integral of v du. This will give you a fair idea of what other components that is needed for you to solve this question, because now you have our u and you have our dv. What other components are left? So when you have the formula down here, you don't have to memorize anything. You have to just look at the formula, derive whatever is left. When you are done, do your substitution back into the formula, and then solve for whatever you need to solve for. And in this case, our du will give us what? Dx, because when we differentiate x here, we are going to have 1 and then dx, as we know already. Or maybe you'll be confused. So let me do something like this. We can say that our du dx is equal to what? 1 for the differential of x. And when we multiply both sides by dx, we are going to have our du to be equal to what? Dx. This is how it came about. Now we have our du. What other component is also left again? We don't have our v. Now we have our u, dv, and du over here. We just calculated it, but we don't have our v. And v can come from the integral of dv. So integral of, into bracket, 5x plus 1 power 1 over 2 can help us find our v. And in doing this, what you can do is that you bring down here the power. What we can do is like it's differentiate whatever is in the brackets, right? When you differentiate whatever is in the brackets, bring it down. So it's going to, or let's assume that when we differentiate whatever in the bracket, take it together with the power and bring them down, and take the original function and add 1 to it. So when we take the original function, we are going to get 5x plus 1 exponent 1 over 2 plus 1 over 1 over 2 times the differential of 5x plus 1 is 5. So this is what you have over here. So having this, you are going to get equal to 5x plus 1 power 3 over 2 all over 5 on 2. All over 5 on 2. All over 5 on 2. But don't forget that when I brought the power here, I didn't add the 1 to here because I added 1 to the exponent. It's not differentiation, to take note of that. So here we are supposed to get, I made some mistake here. So here we are supposed to get 1 over 3 plus 1, and here is supposed to also be the same. 1 over 2 plus 1 should also be 1 over 2 plus 1 times 5. So at the end of the day, you are going to get 3 on 2 times 5, and then the whole function itself is also power 3 on 2. So in this case, you are going to get the numerator to be 15, which is 5x plus 1 power 3 on 2 over 15 over 2. And doing your reciprocal and putting things in place, you are going to get 2 on 15 multiplied by 5x plus 1 exponent 3 on 2. So now you have your value of what? V. So now you have, by checking whatever you have your u, you have your dv, you have your v here, and then you have your du here. That means that we are good to go according to this formula. So doing this, whatever you need to do is substitute it inside the formula, and in doing that, what we can do is that we have to rewrite the formula again, which is what? Integral of u dv equal to uv minus integral of v du. Now where is our u? Our u is x over here. Our u is x over here. So put it there. Put it there. Someone also say that this one, for integrating this, I use a shortcut. But someone can also decide to apply substitution here to kind of simplify it, as we did earlier on, to be able to calculate for your v. But for me, I use a shortcut, and that's why I arrive at the same answer for the finding of v. So having this, now you have your integral of u dv equal to uv minus integral of v du. So by substituting it into the formula, or if you like, I can also do the substitution for you before I substitute it. This one, remember that I use a shortcut, but this one, we assume that we don't know, so let's use a substitution. Maybe some people may like that. So our dv equal to integral of our 5x plus 1 power 1 over 2 dx. Now we want our v, so here we come v equal to, let's u, or let's assume that we are dealing with, okay, let's k equal to, because we are already using u here, so I don't want to make things confused for you. So what we can do, let k equal to 5x plus 1, and therefore we can say that our decay dx is equal to 5. So making dx the subject, we are going to get dx equal to decay over 5. But don't forget that as soon as we represent k equal to 5x plus 1, the question changes to integral of k power 1 over 2 dx. And therefore, since we want it in terms of k, we need to replace it by dx. And replacing that, we are going to get k power 1 over 2, and then dx is decay over 5. So having this, you'll be able to integrate this one, because that becomes simpler enough for us, as we did in our substitution. Because I am not supposed to do this, but because of clarity, and maybe some people may want to get some recap of what we did in the substitution part. So this, I know this may help. But if you know you have not watched the previous videos, please go back and start it. So having this, now we are going to have bring our constant out, which is 1 over 5 was our constant, integral of k power 1 over 2 dk. So now we are good to integrate it. So integrating this, we are going to get k power 1 over 2 plus 1 over 1 over 2 plus 1, which is equal to k power 3 over 2 over 3 over 2. So in doing this, we are going to get k power 3 on 2, or because when I bring this one up here, we are going to get 2 over 3. And don't forget that we have 1 over 5 here, so multiply by 1 over 5. So at the end of the day, we are going to get 2 on 15 k power 3 on 2. But remember that our k is equal to 5x plus 1. And therefore, we can see that we have our answer to be 2 over 15 5x plus 1 all power 3 on 2. So this is the same when you use the substitution. But for me, I use a shortcut, and the shortcut is that when I have 5x plus 1 and then I have 1 over 2 dx, it's the same as the power rule as you do, but the one in the bracket like this, what you can do is that if it is differentiation, you take the power, you differentiate whatever is inside there, and you multiply by the whole function itself, and then you subtract one power from the one from the power. But because it's integration, instead of multiplying whatever result that you get, you take the power and you differentiate here, we divide, right? So when I take the power, it's the integration. So 1 over 2 plus 1, I'll get 3 over 2. That's the power. So what you can do is that take the function itself. When you take the function itself, it will be 5x plus 1. As you do, add 1 to the power, so we are going to get 3 on 2. And you take the power, you differentiate whatever is in the brackets, and you divide. So when I differentiate whatever is in the bracket, I'm going to get 5x plus 1, I'm going to get 5. When you get the 5, multiply by the power, so it's 5 times 3 on 2. At the end of the day, you are going to get 5x plus 1, all power 3 on 2, and then divided by 15 on 2. And at the end of the day, when you do the reciprocal, we are going to get 2 on 15, and into bracket 5x plus 1, all power 3 on 2. I know this is simple enough for you to do if you really understand that, and it's a shortcut form of the substitution without going to elaborating them. But I think if you want to use that, you can use that. But if you are comfortable with the substitution method, use substitution to make your life simple as possible. So now let's come back and then put it back into the formula. So as I said earlier, the formula is integral of u dv equal to uv minus integral of v du. So having this, putting in the formula, we're going to get x, because our u is x, our dv it's square root of 5x plus 1, right, dx, and then it's equal to, where is our u? Our u, it's x, as I said. Our dv, it's 2 over 15, as we calculated over here, square root into bracket 5x plus 1 power 3 on 2, right, minus the integral of, where it's our v. When we calculate for our v, this is our v that we calculated for, but where is our du? Because our du here, we did it here, which is what? Dx. So our du is dx, so, and our v is going to give us 2 over 15 5x plus 1 power 3 on 2, and then dx. Now that you have this, what you can do is just use the substitution method as we did earlier on to calculate for the integral of this function, because this has become a simple one with one term than the one which was given. Or you use the shortcut that I taught you to solve this one. And when you are done, you are going to get your answer to be 2 over 15x, right, into brackets 5x plus 1 all power 3 on 2. This is the term here, right, minus now the integral of this. Either using the substitution or the shortcut, you are going to get 4 over 375 into bracket 5x plus 1 all power 5 on 2, and then don't forget that it's indefinite integral, so plus c. So since you have been able to solve this question, I hope that you now understand what and how you will be able to apply the integration by parts. And not to waste much time, I would like to give you one trial question to look at, and then from there I'll send you into the subtopics and some of the cases that you need to be aware of whenever you are applying or you are using integration by parts in any question that you will encounter. So try this question, which is the definite integral of with a limit from 1 to 2 of ln of x using integration by parts. And at the end of the day, you are supposed to get your answer to be 0.386. So please try a hand on it. Thank you for watching, and see you in my next tutorial, which is repeated